Hope everyone's having a great Tuesday so far. All right. So, good morning. Love Tuesdays. It's like Wednesday, but early. Now that's some thinking. That is some thinking right there. So then do you by the transitive property love Mondays as well because it's like Wednesday but even earlier? Like I think that's a possibility we have to consider. All right. Well, let's go ahead and jump into this. So we talked yesterday about these first two FRQs using that table and information about derivatives. Okay, a lot of like increasing, decreasing, inflection points, relative mins and maxes. Okay, what does it mean? How can we find stuff? And then for number two, we had to use a graph and still some like increasing, decreasing, relative min max, inflection point type stuff. But then we also had that last question where we had to find specific values using the area, okay, and just knowledge about how to find areas to find specific values of a function. And brought it home with finding the equation of a tangent line. All right, so let's do 3 and 4. Which are kind of similar style. They're related in the ideas that we're using. So I guess we'll just go ahead and go for it. Let me pull up my stuff. Okay. So the graph of the function f above consists of 6 line segments. Let g be the function given by g is the integral from 0 to x of f of t dt. I'll get the hiccups. All right, so I think this is definitely going to be very important for me to figure out before I even look at what the questions are asking me. It's defining a function as the integral of another function. Keep in mind this is the graph of f. All right, so always look at the labels of your graphs and see what in the world is it actually the graph of, because it might not be what you thought it was. And let's look at part A. Part A says find g of 4, g prime of 4, and g double prime of 4. Okay, so 3 different values that I need. So I'll first start with g of 4. And remember how g is defined. It's defined by this function. So I'm just going to use this from 0 to x, but x in this case is 4. F of t dt. Now, again, whenever I think about this integral, do I actually have an equation that I can integrate? No. All right, but I do have this graph. So in terms of the graph, we have to be able to make the connection and say, oh, integral represents what on the graph? The area under the curve from 0 to 4. So that would represent this area and this area. All right, from 0 to 4. The area between the curve and the x-axis is more specific, but we say area under the curve. And looking at these shapes, I'm excited because I have a I have a triangle and a trapezoid, which I know the area formulas for both, or at least I have to second guess myself on the trapezoid one sometimes, but I think I know it. So area of a triangle, 1/2 base times height. And I am going to use -2 there because remember the area below the x-axis counts as negative. So the triangle is -1 plus the area of the trapezoid. So area of a trapezoid is the height, which is 2, times base 1 plus base 2. So it doesn't matter which one, it's top or bottom is base 1 or base 2. So this top is a length 1 plus the bottom of the trapezoid, which is length 3, all divided by 2. So that just equals, that second area of the trapezoid is 4. Boom. So G of 4 is 3. And we were able to determine that just by looking at the area of the graph and actually calculating that area. Okay, so we did G of 4. Let's go to G prime of 4. Now, remember, G is based off of taking the integral of f. So G prime of 4, that's just the same thing as asking for f of 4. Right, G is defined as, we get that by integrating f, so the derivative of G would just give me f itself. Right, it's kind of like the derivative and the integral cancel each other out, just leaving me with f. So f of 4, we can just go straight to our graph. 1, 2, 3, 4. We can see that at 4, the value of f is 0. And thirdly, G double prime of 4. So another way of thinking about that is f prime of 4. So I have a graph of f. My question is then, can I figure out f prime? So I want to know, what is the derivative at this point, right, of this graph? Well, look at what's happening. This is just a line. So in general, usually we would need an equation to figure out the derivative so we could find the slope of the tangent line. Okay, but this is just a line. So I can just look at as long as I know the points, I can just look at a graph and figure out what the slope is. All right, so I'm looking at this green piece, and if I ask myself, what is the slope? So we can do any number of things. We could use this point and this point, or we could use this point and 4, 0, whatever, but because it's the same slope throughout that line. So we figure it out. So just do rise over run even, so I can see from one point to the next it's going down 2 and to the right 1. Down 2 to the right 1. That would be -2 over 1. So -2. So it's part A. Part B. Does G have a relative minimum or a relative maximum or neither at x equals 1? Now, again, this is asking about G. Right? So we know f is the derivative of G. So normally if the question asks us, is there a relative minimum, is a relative maximum? Well, we would find the derivative and say, okay, is the derivative changing from negative to positive, or is it changing from positive to negative? That's how we determine, through that first derivative test, is there a min or max here, relative min, relative max. So at x equals 1, that means we're focused on this point right here. Let me use a different color. Right. At this point right here, what's happening to f? Well, f is going from a negative value to a positive value. Well, wait a minute. F is the same thing as it's the derivative of g. So that means that g is going from decreasing to increasing, right? Its derivative is negative and then goes to positive. So what does that mean? If it's decreasing, so it's going down, and then switches to go increasing, it's going up. So that means there's a relative minimum at x equals 1. And as it says up here, justify your answer. Okay, so we have to actually say how we know that. All right, that's a big part of it. That's half of the points on this particular part just comes from the justification. Since G, since G prime, which is the same thing as F, changes from negative to positive at x equals 1. Inception. Oh, RJ's watching Inception right now. Cool, cool. Pretty trippy stuff, man. Right. What movie is everybody else watching right now? I've got on Trolls World Tour off to the side here. That's why I keep looking this way. It's amazing. Incredible piece of work. Ooh, oh shoot. I'll be right back. I forgot something. All right, I'm back. Forgot to take my medicine this morning. Had to go do that. Oops. Let's see what kind of movies we got going on here. Pain and suffering. That's true. All of the Terminators simultaneously. Wow. That's intense stuff. I can't handle that. So good for you. Right. Cyberdyne Systems Model 101 T800 series. Okay, so there's part B. Let's get part C. Suppose that f is defined for all real numbers x and is periodic with a period of length 5. The graph above shows 2 periods. Given that g of 5 is 2, find g of 10 and write an equation for the line tangent to the graph of g at x equals 108. All right. Now this looks like a lot. And it's a little bit complicated, but it's not bad. So first off, telling us that it's periodic, we can see that already, right? In that this graph looks like it repeats, right? It has the same pattern over and over again. I'm going to erase all this stuff up here. Give me a fresh graph to work with. All right, so periodic just means it goes in cycles, right? Like a sine wave. All right, it just cycles. It goes through the same stuff over and over again. So kind of the same deal here, right? So there's the cycle, and then it goes again. All right, and so it tells us it's periodic for all the real numbers. So actually, if I expanded this graph, I would see that it would just continue doing the same thing this way and the same thing this way, etc. It would just repeat. Okay. So it's asking us for a lot of stuff. So let's actually do it over here. Okay, so part C. So the first thing it says is find g of 10. Okay. Find g of 10. So let me just think for a second. So same thing. If I use the formula, all right, if I'm given what I have in the beginning, all right, that just comes from this right here. Just plugging in 10. But what does this represent? That represents the area under the curve. From 0 to 10. And the problem already tells us g of 5 is 2. All right, so it kind of does some work for us, actually. So it tells us from 0 to 5, if I look at all these areas, I guess I kind of outside the bounds there. The problem straight up tells us g of 5 is 2. So it tells us that area that I just shaded is all 2. Now we found those areas as well. Right, or at least parts of them. In part A, we found part of the area from 0 to 4. So now from 0 to 5, it tells me the area is 2. Well, great. Now the other thing is I know that this function is periodic. So I know that this is just going to repeat. And this one goes from 0 to 5. That gives me an area of 2. So if I want to go from 5 to 10, and I'm thinking about what is the area going to be under that curve, well, it's the same pattern, just repeated again. Right? And 10 is just a multiple of 5. So from 0 to 5 will give me one of the cycles. So then 5 to 10 will just give me another same cycle. So actually, this is just going to be 2 All right, that'd be the same thing if I just looked at the integral from 0 to 5 and then multiplied it by 2. But we already know that integral from 0 to 5 is also 2 because the problem told us. Or if the problem didn't tell us, we could have still just calculated the areas using area formulas. All right, so g of 10 is 4. Your dog won. Well, congratulations to your dog. I always believed in it the whole time. Even when everyone else said that it would never win, I always kept believing. And now he won't stop barking. Well, he's excited that he won. All right, we don't all win competitions every day, okay? Some of us have never won a competition ever. I don't know who that is, but so let's just let the dog bark and be excited and celebrate the big win. There's no sports on right now. All right, all the ESPN plays is replays of like the 2007 NBA semifinals. So if we got to celebrate this dog sports now, then okay, all right. So g of 10 is 4. Great. Now, I also want to write an equation for the tangent line of g at x equals 108. Okay. Write an equation for the tangent line of g at x equals 108. Okay, so since it's the tangent line of g, I'm going to need to know g prime. All right, but g prime, oh, wait a second. Did I skip something? No, I'm good. Okay, I thought I missed something. All right, we're fine. So the slope of the tangent line m, so that's going to be the derivative of g at 108. Well, remember, f is the derivative of g. So this is basically just asking, what is f of 108? Well, f of 108, my graph does not quite go to 108. But my graph does just repeat cycles over and over and over and over and over and again. Right? It's going to be the same exact pattern. And it goes in increments of 5. Right? 0 to 5, one of those patterns. 5 to 10, 10 to 15, 15 to 20. So if I think about multiples of 5, if I'm trying to get to 108, 105 105 is when a new pattern, a new period will start. Right, and so that'll look like it'll look like this. And so I want to know at 108, what is it? Well, so if 105 is the starting point here, so 106, 107, 108 would basically be like where that 3 is. So what's the y value there? 2. So f of 108 is 2. This is by no means drawn to scale. And it's actually a pretty crappy drawing. Oh, come on, it's a classic. You don't remember that? 2007 NBA semifinals, 1 year. I mean, it's true. Like, isn't it? They've been playing so many, and it's all like, it's like the Heat days, you know, like LeBron, Bosh, and Wade against the Spurs, or against all those 2000s finals, or just anything with LeBron in it, pretty much. Okay, so this is my slope. The slope of the tangent line is 2. So now, what I need to know is what is my x1, y1? I'm going to use a different color. Well, I already know my x1. Right, that's 108. That's the x value that we've been finding. So what is the y value? I don't know. Well, remember, this is talking about the tangent line of G. So what I need to know is to find that y value. Usually to find a y value, we just plug in the x value. So what is G of 108? Great. Zero to 108 ft dt. So again, let's remember that G is periodic. Okay, it just repeats over and over and over again. We know that the area for one period is 2. Right? Remember, we have that this area right here for all that shaded portion of one cycle. That area is 2. Okay, well, how many cycles would it take to get to 105? Okay, well, let's maybe let's see, 105. 21. That makes sense. So I could say, well, that's the same thing as 21 cycles so that's from 0 to 105, or sorry, not 105, 0 to 5. But that just gets me to 105. So let me add on from 105 to 108. It's not a full cycle, but we can calculate it. So we know from 0 to 5 that integral is just 2. And then plus, so 105 to 108, let's look. That would be, so the cycle would start at 105, and we go 106, 107, 108. So just from here to here, Okay, just that area. Well, we can just do area formulas. Right? 1/2 times base times the height. And then for this second area, it's a trapezoid. So the height, which is 2, times the sum of the length, the sum of the base lengths. So that top base just has a length of 1, plus the bottom base just has a length of 2, all divided by 2. So this area equals -1. This area equals 3. So we have 42 plus 2, 44. Let me double check my work. Yeah. Okay. I guess I shouldn't circle it because that's not like our final answer. But what that is, again, remember, is my y value, my y1. So since I'm trying to find the equation of a tangent line, I can do that now. Y minus y1 equals m. The slope we figured out was 2 times x minus x1. So this was at 108, so x minus 108. And then it's just simplifying. 2x minus 216. And then add 44 to both sides, so y equals 2x minus 172. Double check. And actually, I think this is one of those instances as well where you'd be fine stopping here. I don't think the simplification part, going all the way down to this, is necessary. This is just putting it into slope-intercept form, but it doesn't ask specifically for slope-intercept form. So actually, probably that first, where that first red arrow is pointing, would be sufficient. All right. Let's go on to our next part then. So number 4. The functions f and g are differentiable for all real numbers, and g is strictly increasing. Okay. The table above gives values of the functions and their first derivatives at selected values of x. The function h is given by h of x is f of g of x minus 6. Okay, I feel like that'll be really important. Again, anytime it gives you it defines a function for you, you're going to need to use that. So just f and g differentiable for all real numbers. That seems useful. G is strictly increasing. Okay. So let's take a look. Part A. Explain why there must be a value r for r between 1 and 3 such that h of r is -5. Aha. Okay. So part A. Explain why there must be a value r between 1 and 3 such that h of r is negative 5. All right, well, the first thing I'm going to do is I'm going to look at h of, since this is asking about h of something to make negative 5, I'm going to look at h at 1 and h at 3. So h of 1, so that's based on the definition, that's f of g of 1 minus 6. So let's look. G of 1 is 2. F of 2 is 9. And then 9 minus 6 is 3. All right, so we did this last year at a point, okay? If we're just trying to find values, we just follow it around the table, right? G of 1, use that number, then plug into f. So find f of that number, and then it tells us to subtract 6. So we subtract 6, we get 3. Okay, and I'll also look at h of 3. So that's f of g of 3 minus 6. So g of 3 is 4. F of 4 is negative 1. Negative 1 minus 6 is negative 7. Okay, so what's interesting is I can see that h of 3, now again, this question asks me about this value negative 5. So h of 3, which is negative 7, is definitely less than negative 5. And negative 5 is definitely less than 3, which 3 is h of 1. We know from the information told to us that h is continuous, right? Because it tells us that it's differentiable. So just by looking at this cool information here and then knowing that it's continuous, then we can immediately state there must be some r, I guess let me say r between 1 and 3. Such that h of r equals negative 5. And how do we know that? Because we have to justify our answer. That is by the intermediate value theorem. Okay, so going back to last semester, the intermediate value theorem. Since the y values, right, negative 5 is between the y values of those h, of those bounds, then that means there does exist some value between 1 and 3 that would equal negative 5 if I plugged it into h. Right, it does exist. Now again, to think about what this actually means, so let's say 1, 3. Right, we'll say that's the point 1, 3, right, that we get from 1 and 3. And then the point 3, negative 7, we'll say somewhere down here. And then somewhere over here is where the y value negative 5 is. And so what the intermediate value theorem basically says is if I want to connect these 2 points, and if I know the function's continuous, which we know because the problem told us it's differentiable, then at some point we're going to pass through that y value of -5. We don't know where it'll happen specifically, but since our function's continuous and since the y values are surrounding that -5, then that means there's some x value here somewhere in this pink stuff. There's going to be some x value that if I plug it into h, it's going to give me that y value of -5. Right? It just has to pass through there. We can't skip around the getting a y value of -5. So that's what the intermediate value theorem tells us. Part B, explain why there must be a value c for a value for c between 1 and 3 such that h prime of c equals -5. All right, so this is asking me about the derivative of h equaling -5. So I want to prove somewhere on the graph of h, I'll take the derivative and it'll be -5, right? Somewhere that's specifically between 1 and 3. This sounds like a mean value theorem problem. So let me first calculate the mean value. Right, so I'm just using basically the slope formula, average rate of change, right? Mean value. H of 3 minus h of 1. We already calculated h of 3 and h of 1. So -7 minus 3, 3 minus 1, -10 over 2, and -5. Oh, look. The average rate of change is -5. Again, we know that h is continuous and differentiable because h is just made by using f and g, and the problem told us that f and g are differentiable. Okay, so I guess I'll put that part in here. It is differentiable and continuous. Then there must be some c that's between 1 and 3 such that the derivative of h at c is -5. And how do we know that? That is by the mean value theorem. Note that the question specifically asked us about the bounds, right? Some c between 1 and 3. That's why those are the values that we use to find the slope, right? The average rate of change. H of 3 minus 1 divided by 3, H of 3 minus H of 1 divided by 3 minus 1. It's because those are the bounds that the question asked for. The question specifically asked, does there exist some number between 1 and 3? So that's what we used. I think typically there's a lot of confusion of mixing up when to use which theorem. Okay, here's the best way of how to know. Come on. is, now this sounds like a stupid tip, but look at what the question is asking. If the question is asking for the actual value of the function, right? Is there something that h of r will be -5? It's probably going to be an intermediate value theorem problem, right? If it's talking, and it's talking specifically about between two numbers. So if you see a question that says it's talking about a number between two other numbers, and you're trying to hit a goal of will the function equal some value, it's probably going to be intermediate value theorem. Now on the other side, if you're being asked a question about the value of the derivative, right? H prime of c is -1, and you're given some bounds, so between here and here. Mean value theorem if you're trying to find the value of the derivative. Intermediate value theorem if you're trying to find the value of the actual original function. All right, I hope that makes sense. Mean value theorem for finding value of a derivative between two things. Intermediate value theorem for finding the actual value of a function that's between two things. Okay, let's do part C. Let w be the function given by w, is 1 to g of x of f of t dt. Find the value of w prime of 3. Okay. All right. So the first, in order to find w prime of 3, let me first just find out what in the world is w prime. Okay. Now, it's been a while since we talked about, so I'm just going to copy down again what w is. So 1 to g of x, right, of f of t dt. Okay. If I want to find the derivative of a function that is defined by an integral, this is the second fundamental theorem of calculus. Again, talked about it in Calc AB. Right? If we're trying to find the derivative of a function that is defined by an integral, use the second fundamental theorem of calculus. And that tells us this. So we take our function, whatever it is, and we plug in the upper bound, but we have to use chain rule. So that's times the derivative of the bound. And then so that would be minus the function plugged in by the lower bound, so the lower bound is just 1, times the derivative of the lower bound. Well, the derivative of 1 is 0, so times 0. Okay, great. So I don't even need to worry about that second term. Right, so this is my formula for w prime. Great, so if I want to know this, well, my goal is to find w prime of 3. So f of g of 3 times g prime of 3. So g of 3 is 4. f of 4 is -1. Okay. So -1 times g prime of 3. G prime of 3 is 2. It's 2. So w prime of 3 is -2. Second fundamental theorem of calculus. Right, so if you're confused about that or want to look at that more, go back into your notes from AB, look at that up. Look on that AP test review, AFA, right? Some of those cheat sheets that have the formula there, or the website that has all the different practice problems. So you can just choose a section, go choose second fundamental theorem of calculus, do some practice. Okay, but that is what happens. So that means we plug in the bounds. But then you also have to multiply by the derivative of each bound. All right, because of chain rule. All right, so there's part C. It's been a while since we've done that. Part D, if g inverse is the inverse function of g, okay, that makes sense. Write an equation for the tangent line of the graph g inverse of x at x equals 2. Okay. So if I need the equation for a tangent line, the first thing that I need is to figure out what is the slope of the tangent line. So I need the derivative of g inverse. So g inverse, I need the derivative of that at where? Where does it ask us to find the tangent line? It says at x equals 2. All right, so this is the derivative of the inverse at 2. Okay, now here's something that we definitely did not talk about very much. All right, I mean, we talked about it for a couple days, but not anything super long. I had to go back and make sure that I had this formula correctly because I was not confident at all. Right, but in AB there was I think like 2 days that we talked about properties of finding the derivatives of inverses. All right, and so it is this. The derivative of the inverse of g at 2 is the same thing as 1 over the derivative of g inverse of 2 right. So that's a property that we use. This is basically just like a formula, right? For finding derivatives of inverses. Okay, so g inverse of 2, I can figure out that. So I'll leave this other stuff the same for now. So 1 over g prime of, but g inverse of 2. So g inverse, if I look at this table, I just go backwards. Right, so instead of, if I wanted g of 2, I would say, okay, g of 2 is 3. But that's not what this is asking. This is asking G inverse, right? So we kind of have to flip everything. So G inverse of 2 basically says, okay, what value does it take to get to 2? What value do I plug into G that would give me 2 as the answer? Well, so I just look over. That would be 1, right? G of 1 is 2. All right, so G inverse of 2 is 1. My big dumb head's in the way. Oh, no. Oh, no. Well, this is broken, so forget it. And you might remember we've talked about before and talked about last year, well, inverses, how are the points of inverses related? Well, the order's just switched. So we can see that here as well. Instead of 1, 2, it's 2, 1. All right, so G inverse of 2 is 1. Right, those are the same. And now G prime of 1. Well, let's go back to my table. So this is just asking for normal G prime. So G prime of 1 is 5. So this equals 1 over 5. So what in the world is this? 1/5 is the slope of the tangent line of G inverse at x equals 2. But the problem asks us for the actual equation of the tangent line. So I have the slope, I have the m. What's my x1, y1? Right, for G inverse. Oops, flipped it. Right, 2, 1 is my x value and my y value. So y minus 1 equals 1/5 x minus 2. And again, we're okay with just stopping there. We actually don't need to go through and put it into slope-intercept form unless it specifically asks.